Hello guys, and welcome back to the last video of the series, and this is a tutorial series on how I did this sofa, this parametric sofa with geometry nodes. And if you haven't seen the previous videos, just go in the description down below and find the other videos and go watch them, because watching from the start this one without seeing the previous three is like not very logical thing to do. And you can download this file on Gumroad for just $2. It's not much, and it will help me to keep this channel running and keep it alive for as much as I can, so it would be highly appreciated. Anyway, let's go ahead. And let's, we needed to create our cushions. That's the last thing we had to do. So let's just see what these cushions are made of. Okay. Already explained to you this back thickness, true cushion width. Okay, this is the back thickness. I already shown you in the last video what these group nodes are, so go over there to check that. This is our cube that's going to become our cushion, and then this is our combined XYZ node and our X value and our Y value. Our Y value is the width of the cushion, and it depends also on the sorry, oh my god, where is it? Okay, it depends on the size of the back. So if I remove the side, so the cushion depends on this direction, on this dimension, and also on the nosing dimension. And so if we go back, okay, so the Y dimension is the nosing that gets added to the depth from which is subtracted the back thickness, and the X is this true width cushion. That's also a group node that I created and just grouped it because I will need that true cushion width, and that is this. And that's, we can go inside of it to see what happens here. So we have like side cushion, yes or no. This is a value that's going out as 0, 1 or 2 if we want the side cushions, yes or no. And that will be subtracted also from the as well as the side. So the side and side cushions needs to be subtracted from the width. That's what's happening here. Side and the side cushions are added and then subtracted from the width to get to the, and then this dimension needs to be divided by the number of cushions, because it's not the same size if we have one cushion on the width of 2 meters or 3. So we need to divide that number by the number of cushions, and then we will have our true width of one cushion. Okay, and that is our Y, and our Z is very simple. It's just our cushion thickness. And then the transform, of course, we need to place it in the middle of the middle. Let's just see. Okay, I just moved it here with this node on the Z-axis, so that is here on the base. So just height of the cushion divided by 2 on the Z-axis. Okay, and then let's go ahead. What we did here. Okay, we did that puffiness thing. So again, I selected this loop cut in the middle, and I moved it on the Y depending on the back cushion thickness. So my back cushion thickness, that's what I was drawing the last time. I don't know if you remember Not sure if I want to do it again. So this is my cushion here, and the other cushion is going like this. So we need to have this loop cut coming here, and then bring this vertex up here so it closes this gap. And that's what I'm doing here. And that's why, as you can see, that's why if I decrease the back cushion thickness like this, you can see what happens. But you also see that sorry, let me delete this. This angle remains the same. It's the same angle of the back cushion. It's 1:5 ratio, and when back cushion thickness increases, you see that the angle stays the same, but I'm moving these, and it's just a bit of math to do that. Just a bit of math, nothing much. And then of course I did the same thing on the other Y direction, but I left this here because here comes the cushions. If there are no cushions here, so back cushions, back cushion, no, look what happens. Everything goes up, and we control the puffiness with the back cushion thickness, puffiness. Remember. Okay, perfect. And then we go into our subdivision surface, and this one is a bit different, since I needed and wanted the stitching. So how do I did the stitching just by isolating a loop cut of these, but that was really challenging to select this loop cut, because as you can see, especially if there are back cushions, when the back cushions are here, you see that and if back cushion thickness, and if it's like this, you see that these cushions get really deformed, and it's really difficult to select just like I wanted this loop cut here, going all over. And it became, I tried everything. I tried compared to like a distance, compared to height, to z value, all these indexes here have like nothing in common. So I did the worst possible boring thing that I can think of. I did it with the help of an index node. So index node, remember the position node here, that's also field. Index is a field, but this position that we talked about in the second video, or the first video of tutorial series, this one sends out the X, Y, and Z position values here, and then we separate it and whatever. But we have also the ID node. Oh, sorry, what did I do? SID. This. And this one sends out these numbers here. So every single vertex here has an ID number. But unfortunately, Blender sends out ID numbers really kind of there is a logic to it, but that logic didn't help me in this case, because it sends out IDs like this. First, before the subdivision surface, before the subdivision surface, he assigned these IDs, and this vertex here is always going to have an ID number, the same ID number even after the subdivisions. You see, now we have 56 of them. So the first 56 vertices are already taken, the IDs. Then When I do one level of subdivision, then it gives out the rest of 218 minus 56 vertices, their IDs, and then after that, when it's two level of subdivision, it gives out the rest of the IDs. So it was quite impossible to find like a pattern to these loop cuts. So I did the most boring and stupid and the only thing that I could come up with, even though lately I've been hearing about there is like a attribute capture attribute, something probably can be done with this, but I didn't I didn't look into it until now, and I'm sure I'm gonna try to figure out how would it be done in a more easier manner. And if I do realize, and if I do get it, I will write it in the description or in the first comment anyway of this video. But I will show you how I did it. So I needed a selection of these vertices. And how did I do that? I actually did this. This is a selection. Let's go into it. Ooh, look at it. Look at it. You know what this is? These are the exact IDs of every single vertex here. So this is vertex 56, vertex 104, vertex 107, 110, 113, and all 800 and something vertices here are selected. Well, not 800, but there are 800 from all the 866. I don't know how much I need them. I don't know how many nodes are here. Anyway, and with a lot of Boolean math, so or this or this or, and it comes out selection exactly this. These loop cuts. This is what I wanted. This is what I wanted. This is the geometry I needed. And so I separated like my subdivision surface here. I let it go ahead, and the other one I use this delete geometry and selection, and after I selected all of them with the Boolean not, so I delete geometry, all the other vertices. Then I created a mesh to curve, because this is a mesh, and then it needs to be a curve, and then again this curve needs to be a mesh, but I also plugged in the profile curve, and the profile was a little circle curve like this, nothing special, with the Cushin stitching stuck into the radius, so we can control the radius of this curve. And then I join them all together right here. You probably are asking yourself on how I found all these IDs for each single vertex. And what did I do? I will show you here, or I will show you in another example with another different node, so I don't ruin everything. Okay, so let's just add like cube, and let's subdivide it. Okay, and then let's add set position. No, not set position, sorry. Let's add instance on points. And let's instance UV sphere. But just scale it a lot. Okay. And of course, let's just duplicate this geometry. Shift A-S, join geometry. Let's move this a bit down and join like this. So we have, and so what did I do? ID, selection, and compare. Shift A, S, math node. Compare. Where is it? Where is it? Compare. Epsilon 0. And selection. Okay, so what am I doing here? So I want the value here is going to be RID. So this one sends out. Let's just turn this. Just turn our like wireframe. Okay. Okay, so I look at it here. So if ID, the vertex here, is 1, then it will place an instance here on that point, on that ID'd point. So if the value is 50, then it will place it. Now we don't have a 50th vertex, we only have 26, so let's 20. So this is the 20th ID'd vertex. So what did I do? I plugged this number into here, and I said this was gonna be this was gonna be an integer, and then I was able to switch it like this. And as you can see, when I switch this number here, this UV sphere moves. And what did I do for our cushion? So I placed the cushion in one of these orthographic view, where I was able to clearly see the loop cut I was interested in, and I was just like doing this. And when it went on my loop cut, I just wrote down the number, and I wrote, I don't know how many numbers, that I then see like this. No, this X value. Okay, this X value showed me exactly where this icospheres was showing, and that's where that's the numbers that I used in this groups. These numbers. It took me about an hour maybe to do that. Okay, so we got our stitching, and then we needed to transform it so that it, okay, this is the back cushion, because everything for the cushions, this is the front one and this one is the back one, and everything remains the same. And I kind of joined these, the back cushion and the horizontal cushion. I joined them together here like this, and I used this geometry here coming out of this node. I used it to instance it here on a mesh line that I'm gonna explain in a second. But before, I just wanted to say how I used also the switch node. Where is it? The switch node here to turn off the back cushions. So, got it? If it's true, then it sends out, and if it's zero, if it's false, then it gets cut out and we don't show it. So I instanced it. I instanced this geometry on a mesh line, and this mesh line, it's also a lot of nodes, but it's kind of simple, where this mesh line needs to be the vertices of this mesh line need to be the position of the cushions. Since we have 1, 2, 3, or 4, 5 cushions, this mesh line changes its vertices. You can go check out the video that I made on the parametric stairs, and that's where I explain in detail how to do this exactly. And even though it was used with attributes at the time, the technique is the same, and I don't want to waste your and my time, another 15 minutes, to explain something that I already explained in that video. So if you really want to see how I positioned and created this mesh line and these vertices here that then get instanced like this, number of cushions, then go check out that video over there. Okay guys, so we're getting closer to the end, because all that's left is the side cushions, but I think we've already went over that. Just let me see if I did something. I'm always using this Boolean vertices group, because the indexes, the IDs are staying the same if you do the same operation as like a subdivision surface, and you have the same amount of vertices. So it worked perfectly also for other geometries. The important thing was to have the same number of vertices. So if I was to have like 5 vertices, then my ID here would be useless. Look at it. These IDs have absolutely no logic whatsoever. Anyway, but with exactly 4 by 4 by 4 vertices, perfect. And this is my side cushions. The same thing happens: subdivision surface, transform, place it here, duplicate it with the join geometry node, switch it on and off if you want 1 or 2. Since I don't have it, where is it? Side cushions 0, 1, where is it? 1 or 2, perfect. And then send it out after assigning switch, of course, and set material and shade smooth. The same thing we did with all of them, and this is practically it. And all these nodes come together here. And the last thing I did, so this is practically a done deal. Let me just, it looked really weird. Okay, and the last thing I did, I just passed it through the transform node and I translated it. Now it's muted with the M. See, M unmuted, M muted. The last thing I did is like placed everything like its origin point to here, and it's simple. It's just translation XY axis depth divided by 2 and width divided by 2, and it gets moved here. And why is that? It's just easier to control it when you try to edit something, or when you try to join two together to create like a side or something like that. And because if I was to increase the width, it kind of moves on both sides of these x and y, x values, negative and positive. But if I use this node, sorry, M, oh my god, what did I do? Sorry, tab, tab, M, and then if I change the depth or the width, this point stays stable. You can use it on however you want. So with this muted or unmuted, that's your choice. Sometimes I mute it, sometimes I don't mute it, whatever. And this is it, guys. I think I told you everything. I hope you enjoy this little sofa. Let's just give it a material. I have only one material in this scene, but whatever. It's looking very interesting in my humble opinion. Anyway, guys, thank you so much for watching. Remember, you can download this file on Gumroad, just $2, and it will help me a lot. And you can do whatever you want with it. And stay tuned. A lot of geometry node based videos coming up your way. Goodbye.